Hi, this is Mrs. Young, and this video will be a lesson on surface area of prisms and cylinders. Anytime you're watching a video, remember that you can pause the video, and there will be times that I ask you to pause it to write stuff down, but you can also rewind the video or rewatch the video if there's something that you didn't catch or just need to see again. So for our bell ringer today, I want you to go ahead and copy down the formulas below for lateral area of surface area of right prisms. So make sure you get out your spiral and copy down these formulas with the shapes. So I would say pause the video right now and go ahead and copy this down. A few things that I wanted to mention. The perimeter, capital P in that first formula, that's the perimeter of the base. And then H is your height, which is perpendicular to your base. Lateral means the area around the shape, around the middle of that triangular prism or rectangular prism. And then we add in the area of the bases, which would be the top and the bottom. And that's why there's 2B, because you have a top and a bottom to your triangular prism or any type of prism. A cube is a special shape because all of the sides are the same length. So there's a shorter formula for that because all the faces are the same area. They also give you the surface area for a rectangular prism. Sometimes I just find the area of each of the sides and add them together, or you can use this formula if you'd rather. Also notice down at the bottom, there's a caution. The surface area formula is only true for right prisms. A right prism is a prism where the sides are perpendicular to the base, kind of like where it's standing straight up and down. It is not the same formula for an oblique prism. Luckily, we're not finding surface area of oblique prisms, but I will show you some later. Oblique prisms are ones that are slanted or tilted. So again, these formulas are only for right prisms. Now I have a few problems that I would like you to try. So the first one up here, it says, find the lateral area and surface area of the rectangular prism, and then round to the nearest tenth. I don't even think you need to round on this one. Again, the lateral is around the middle, and then when you add in the two bases, that's your total surface area. Then also find the lateral and surface area for a cube, which with an edge length of 8. I'm going to give you a couple minutes to do that, so go ahead and pause the video now and see if you can figure out or calculate the surface area of each of these. Okay, so for the rectangular prism, my lateral area, again, the perimeter of my base, 9 plus 7 plus 9 plus 7 times my height, which is 14, gives me a lateral area of 448 feet squared. My total surface area is going to be that lateral area plus the two bases. The bases are 9 by 7, so 2 top and bottom times 9 times 7. Add that to the 448, and I get a total surface area of 574. So again, lateral area plus the bases gives you your total surface area. The other thing you could do is just find the area of each of the faces, each of the rectangles, and add them together to get your total surface area. That's just another way that you could have worked that out. The next one that you had to do was the lateral area and surface area of a cube with an edge length of 8. So again, the lateral area, there's 4 faces around the middle that are 8 by 8, so that's 256. And then I add in the area of the two bases, which again are 8 by 8. So you should have a total surface area of 384. So again, lateral 256, total 384. Notice with surface area, because it's a flat surface, my units are still squared or to the second power. Next, I want to give you the formula for a cylinder. So the lateral area of a cylinder, again, the lateral area is the area of that rectangle. If we unwrapped a cylinder, you'd have a rectangle surface going around the middle. So the area of that rectangle is 2 pi r(h). You should recognize 2 pi r, that's my circumference, and then multiply it by the height to get the area of that rectangle. Your total surface area is going to be the lateral area, 2 pi r(h), plus the two bases, 2 pi r squared. Again, pi r squared is the area of a circle. There's 2 of them. That's why we have 2 pi r squared. So again, I want you to pause the video and go ahead and copy down these 2 formulas for cylinder. Pause it. So now we're going to do an example with a cylinder. It says find the lateral area and surface area of a right cylinder with circumference of 24 pi and a height equal to half the radius. It says give your answer in terms of pi. I'm going to actually help you start this one here. Again, we want to find the lateral area and surface area of a right cylinder, meaning it's standing straight up and down, with a circumference of 24 pi and a height equal to half the radius. This is a little tricky. Again, when I see the word circumference, I think of my circumference formula. Circumference equals 2 pi r. So if my circumference is 24 pi, I can plug that in and say 24 pi is equal to 2 pi r. If I'm trying to solve this for r, we can divide both sides by pi. The pi cancels out, divide by 2, and I get a radius of 12. If my radius is 12, notice it said that the height is equal to half the radius, so we know the height is going to be half of that, or 6. So again, I'm going to have you pause the video here using a radius of 12 and a height of 6. See if you can come up with the lateral area and the total surface area of this cylinder. So pause it and do your calculations. So checking your answers, you should have a lateral area of 144 pi. And a total surface area of 432 pi. Again, double check your answers, make sure that's what you got as well, and that you can come up with the lateral area and surface area of a cylinder. Next, we're going to move on to a composite figure. A composite figure, similar to our 2D unit, is when we put two or more shapes together. And here we have three-dimensional shapes put together. One thing that I have to point out to you is that whenever you have a composite 3D figure, we assume that it's hollow in the middle, that I can put something in the middle of this box. So we assume that there's no top on that rectangular prism, and we assume that there's no bottom on that triangular prism when we're doing our calculation. So for my box at the bottom, the rectangular prism, I would do the lateral area and just have the one base, right? Because there's no top on that box. For my triangular prism, I would have the triangle in the front, the triangle in the back, the rectangle on the left side, and the rectangle on the right side. Again, there's no bottom to that triangular prism. So I'd like you to go ahead and see if you can come up with the surface area of this composite figure. Again, make sure you're showing work and labeling it so we know what matches up with what. So again, pause your video here and do your calculations. So hopefully you came up with a surface area of 72 centimeters squared. And you can see how I broke it down. For my box on the bottom, I have a lateral area of 36. The one base, 4 times 2, that's 8. Again, there's no top on that rectangular prism. Then for my triangular prism, the left side is a rectangle, 3 by 2. The top right, or rectangle slanting down the side, that's 5 by 2. How did I know that this was 5? Again, I remember my Pythagorean triples, right? This is a 3, 4, 5 Pythagorean triple. So I know that that rectangle is 5 by 2. So again, this top right surface, this rectangle is 5 times 2, that's 10. And then I have two triangles, the triangle in front and the triangle in back. So again, the two triangles, 2 times, and again, a triangle is 1/2 base times height. So I get 12 for the area of those two triangles. Then when I add all of those surfaces together, I get a total surface area of 72 centimeters squared. As far as composite figures go, this one is relatively easy. So we're going to try another one that's a little bit more challenging. But before I get down there, here's another example of all the work written out with an explanation. Okay, and then down below here we have our next composite figure. So we have a box on the bottom and a cylinder on top. So the box on the bottom, there's the lateral area, there's the base on the bottom, and there is actually a base on top. I would find the area of this whole rectangle, but then realize that you are going to have to subtract this circle from the top of that box. It's like there's a hole cut out. It's hollow in the middle. Also, with the cylinder on top, you have the lateral area and you have a circle on top, but you do not have a circle on the bottom. So again, the lateral of the cylinder plus just the circle on top. But for the box, you have all 6 sides minus that little circle cut out of the top of the box. So again, I want you to pause the video now and see if you can calculate the surface area of this composite figure. Now this one for sure, round to the nearest 10th. You're gonna have to round here. Go ahead and pause it. Okay, so for my surface area, I have 239.7 centimeters squared. For the box on the bottom, the lateral is 130. And then the two bases, the top and the bottom, I have 72. So if I add those two together, I got 202. Then for my cylinder, my lateral, the distance around the middle is 12 pi. So when I add the 202 plus 12 pi, I have 239.7. You might be thinking that I forgot about the circle at the top, but I realized that I was going to have to subtract the circle from the top of the box and then was going to add it in at the top of the cylinder. So I just didn't even write that down. But again, if you wanted to, you could. So the top of your box, you would have to subtract that circle on top, which would be 2 pi r squared, which would be 16 pi. So you'd be subtracting 16 pi. But then down here with your cylinder, when you add in the top of the cylinder, you'd be adding in 2 pi r squared. So you'd be adding in 16 pi. Again, I realized that these two would just cancel each other out. So I just didn't write them down. But it might make more sense to you to include that or write that down. Okay, so again, your total surface area, 239.7. If you need to, pause it and look this over. My last part of this unit, last problem, says the edge length of the cube is tripled. Describe the effect on the surface area. So we're going to find the surface area of the cube, and then if we triple the side length, what happens? So again, for my cube, I know it's 6 times the side length, which is 8 squared. So again, plug that in your calculator. You got a total surface area of 384 for this cube. That's my given cube. Now, if I triple the side lengths, right? If I triple them, 8 tripled, 8 times 3 is 24. So then I could say my new surface area is 6 times 24 squared. Plug that into your calculator. You should come up with a surface area of 3456. So we want to know what's the effect. We tripled the side lengths. What happened to the surface area? How many times bigger is it? So I'm going to take 3456 and divide it by 384. Plug that into your calculator for me and tell me, what do you come up with? How many times bigger is that surface area? I hope you guys have your calculators. If not, I guess maybe use the calculator on your phone or whatever calculator you have handy. When I divide this, you should come up with 9. So we're noticing that if my edge length is tripled, my surface area is 9 times larger, 9 times bigger. Notice that, again, tripling the side lengths, 3 squared is the same as 9. We've seen this before with area, right? That it's your scale factor squared, right? So if I had doubled the side lengths, 2 squared, my surface area would be 4 times bigger. If I had made all the side lengths 4 times bigger, 4 squared would be 16 times bigger. So we have seen this relationship before with area. The same thing holds true with surface area. Finally, what is our homework? So our homework for tonight, let me go to my next slide, is pages 25 and 26 in your packet. I did alter the assignment from your stamp sheet. I took a few problems out just to make it a little shorter for you. So 13 through 26, 32 through 34. You can do those other problems in between there if you want. They're coin problems. When you are done with the homework, again, make sure that you are drawing pictures and showing work. Plug the numbers into your formula. Make sure I can see how you came up with your answer. Once you take a picture of it, go ahead and take that picture and turn it in on Google Classroom. This way I will know that you have completed the assignments, okay? And as of right now, since this is your lesson for Tuesday, March 31st, this homework will be due on Wednesday. So again, make sure you get it done and turned in. Once you turn in the assignments, I will push out the homework answers to you via Google Classroom. Have a good day.